Did you know that men can develop breast cancer, although it is much rarer than in women? Basically, less than 1% of all breast cancer can cause occur in men, yet approximately something around 2,670 new cases of invasive breast cancer in men are expected in the US in 2005. So today we are discussing about how we can use a breast cancer data by applying the neural network. So welcome back to Code Chronicles. Let's start our video. So today we are discussing about breast cancer with neural network. So first we have to import the libraries. Import pandas as PD, where pandas, it's a powerful data manipulation and analysis library. And then we use NumPy as NP, which is basically about the NumPy is for numerical computation in Pythons, which provides supports for arrays, matrices, and a collection of mathematical functions to operate on these arrays. Next, we are using sklearn dot model selection and import train test splits fold. So basically by this that train test splits, so the function splits our data sets into the training and test sets. Okay, and stratifold we are using for the close validation method that ensure each fold of the dataset maintains the same percentage of samples of each classes. Okay, so basically it is particularly useful for the imbalanced datasets. Next, we are using for the sklearn pre-processing, label encoder, and the standard scaler. So basically label encoders are used for class converts categorical labels such as strings into the numerical values, which is often required for machine learning algorithm. Okay, and standard scaler we are using this for the class standardize features by removing the mean and scaling to unit variance. Okay, it is essentially basically for the many machine learning algorithms, especially those that depend on the distance matrix like SVM or KNN. Okay, next we are using the matplotlib. Basically it's a plotting library that provides function for creating a static, interactive, and animated visualization. Okay, now we are using the TensorFlow Keras models, which is where we are using sequential, and for layers we are using dense dropout, and for Adam and for optimizers we are using Adam. So basically Keras we are using for deep learning framework that runs on the top of TensorFlow. Sequential we are using for it's a linear stack of layers where you add layers sequentially. And next we are using dense and dropout. So dense basically it's a fully connected layer in a neural network where each node is connected to everyone in the previous layer. Okay, and dropout is basically a regularization technique which is used to prevent overfitting by randomly setting a fraction of inputs unit to 0 during training. This also helps us to prevent the model from becoming too dependent on specific neurons. Okay, now at the last we are using Adam. So Adam basically adaptive movement estimation. It is an optimization algorithm that computes adaptive learning rates for each parameter. It is widely used for training deep learning models due to its efficiency and ability to handle the sparse gradients. Okay, now we are using the Keras turners. We are using the random search. So basically purpose for Keras turner is a library to perform the hyperparameter tuning, where random search tuner randomly searches through a predefined hyperparameter spaces to find the best model configuration. And last we are using the sklearn matrix, which import the confusion matrix. Basically everyone knows about, like who are into the field, confusion matrix, which summarize the performance of a classification algorithm by compare the predictive labels and the actual labels. Okay, so in the next step we are load and pre-process the data. So basically we download the breast cancer datasets and prepare it for training. So we are using dataset underscore URL. So this is the URL where the dataset is hosted. Okay, so dataset in question in a CSV file which contains the information about the breast cancer's features and diagnosis. Okay, so then we are using column underscore names, and then we are reading the data. Okay, we are reading the data with the data is equal to pd dot read underscore csv. Okay, so if you want to see the data, what we can do is we can print data dot head parenthesis pd is not oops. Okay, so see, you can see the data. So now we are moving to the step 3 where we can encode the non-numeric columns. As you can see in the data, there are so many columns are in the non-numeric and some are numeric. Okay, so what we are doing is we are doing the iterate through all the columns in a data frames. First we are applying the for loop. Okay, it basically iterates all over the column names in the data frame data. Then what we are doing there is it checks the data type of each column. If the column contains non-numeric data, which is a typically a type of object, it proceeds with encoding. Okay, next we print encoding non-numeric columns, so it prints a message indicating that which column is being encoded, and this is very helpful for tracking which columns are being processed. Okay, now at the last we are using the label encoders from sklearn module to encode the categorical coder. Okay, to categorical column into numeric values. Okay, so now you can see encoding non-numeric column is radius mean. As you can see, there is commas, numeric values. So all those are non-numeric columns. So now in step 4 we are encoding the target variables. So basically what actually we are using the label encoder over here, which creates a mapping of each unique category or label in the input column to a distinct integer. Okay, now we are using the fit transform, which is the data is taking a diagnosis. So the purpose of taking a diagnosis, the column data is basically data frame with the newly encoded numeric values. Okay, and in step 5 we are using the split features and target. So basically if features is equal to we are using the data.ilog, where we line selects all the columns except the last one, the target column, as features for the models. And then we are using the data for target data.ilog again with -1. So again the line selects the last column as the target variables. Okay, now we are using the standard scalars. So the line initiates the standard scalars from the sklearn pre-processing that standardize the features by removing the mean and scaling to the unit variance, which is where the standard deviation is 1, which is means the meaning of unit variance is the standard deviation is equal to 1. This is important because many machine learning models perform better or coverage faster when the data is standardized. Models like logistic regressions, SVM, and neural networks are sensitive to scales of the input features. Okay, and we are using the features for features is equal to scalar dot fit transform features. So basically it after scaling, each features will have a mean of 0 and a standard deviation of 1. Okay, suppose if a feature column originally having a value like 10, 15, 20, and after scaling it, it might be the value of -1.220, 1.22. Okay, so depending on the mean and the standard variation. Okay, now in the step 6 we are using the split the data sets into the train and test. Okay, again after that we are using the defining the hyperparameter tuning function using Keras tuner to define and tune hyperparameters. So basically we are using the sequential model. A sequential model is a linear stack of layers where you can add one layer after another. Okay, and basically Keras models which are built by layer. So it is essential for the sequential model to ideal sequential model is ideal when each layer has a single input and output. Okay, when it will be happen, it will be happen when layers are arranged sequentially. Okay, after that we are using the first dense layer over here. Okay, a fully connected layer, dense layer, which is added, and the dropout layer after that. So we having a dropout of 0.1. Okay, so we are using a dropout of 0.1. This is the dropout layer. Then additional layer we are adding for dense layer for hyperparameter optimization. Okay, so where we are having a dropout layer of 0.1 again and to 0.5. From 0.1 to 0.5 we can use this. Okay, now we can add this dense with the activation of sigmoid. Okay, why we are using sigmoid? Basically sigmoid activation function outputs a value of 0 to 1, which make it subtle for binary classification. Suppose we are working on the cancer, so we are predicting cancer or not cancers. Okay, now we compile our model. After that we compile our model. Okay, so basically we are using the Adam optimizer, which is used for the adaptive gradient descent algorithm. The learning rate is set using the hyperparameter search. So basically we are using the hp.choice for 0.001, 0.001 and 0.0001. Okay, this is the learning rate we are choosing. And for loss functions, it is a binary classification problem, the loss function we use the binary cross entropy. Okay, and the matrix accuracy is used for the evaluation for metric the model during training. Okay, now in step 8 we perform the hyperparameter tuning, and where we are using the random search, build model, well accuracy, and for the validation accuracy and maximum trials we are using for the 10, and executions per trial is equal to 2. Basically we are running a multiple executions per trial for allows for averaging the performance to and reducing the variance. And then we are creating the then it will create a directory tuner underscore result, the directory where the tuner will store the result of each search. Okay, so you can go back to the directory and you can see the tuner result after running on this, and you can see the JSON files. Okay, and the trial this like this. Okay, now you can give the project name for the breast cancer classification. Okay, now when you run this, so basically there is a tuner.search we are using. So it with having a batch size of 16 we are using in with the 20 epochs. Okay, so reloading from the tuner result, so you can see the JSON file as I saw you. Now we move to the step 9, retrieve for the best parameters. So basically we are using Turner got best parameters, the number of trials we are using 1. By setting it receives the top trial based on the objective metrics, in the case validation accuracy. That will retrieve the best hyperparameters. So you can see in the results the best number of units is 24 and the best learning rate is 0.01. Okay, so now in the next step we build and train the best model. Now in step 10 we are build and train the best model. Okay, so we are using tuner dot hypermodel dot build best for the HPS during the tuning process. So Now in this step, use the same build model function which you defined earlier, like the optimal hyperparameters such as the number of units in each layer, the dropout rate, and the learning rate. Okay, now we train our model with the history is equal to best model.free and with the epoch size 15 and with the on batch 16. Now you can see the results. It will iterate 50 times. I am giving 50. If I am giving 40, so it will give the, okay, I didn't run the code, so I have to run everything again for this to run on this 40, and now it will be run on 40 times. If you change the, now you can see the X is the test features of the test input, test set, input data, and the ground truth. So you can see our test accuracy is 1. After that, we perform the cross validation. In step 11, you can see evaluate the model. We use loss and accuracy. So you can see the test accuracy is 1. After that, we perform the cross validation. So for cross validations, we are using the feature sets and the target labels X and Y. Okay, and now we are using the model builder over here. Basically a function that returns a build model. The function which is used create a new instance for the model of each fold, and we are splits into the 5 times. Okay, so cross validation number of slits is 5 times. That means the data will split into 5 subsets for training and test, and we are using the k fold. Okay, which creates objects of for cross validation, which ensures that each fold maintains the same class distribution as the original datasets. After that, we apply the for loop over here, which splits the data sets into the n number of 5 parts, and then again it will iterate and return to the train idx to the current fold, and then for the return to the np array scores. Basically it return to the list of accuracy scores of each fold as numpy array. Okay, now this function basically help to build with the best parameters found by the Keras Turner. Okay, now we run the score. So you can see the cross validation accuracy is 1 plus minus 0, and now you can see the visualization of this training history. You can see the training accuracy is 1 and the validation accuracy is also constant. Okay, after that we generate a confusion matrix where we find the precision, recall, and F1 score, and you can see that our model having a good precision, recall, and F1 score. So guys, this is it for the today, and I will see you in the next video.